All right, I'm back for number 17. In this problem, we're identifying the asymptotes. Give answer in exact form, and we're not going to round. So first, equations of the vertical asymptotes. This one is a simple one. I'm glad I don't have to factor. Remember, vertical asymptote happens when the denominator is 0. So you're going to say x plus 4 equals 0. And if you subtract 4 from both sides, x equals -4 is the vertical asymptote. Yay. All right, now let's do the horizontal asymptote. Remember horizontal asymptote in our class, in pre-calculus class, we had to look at the degree of the denominator and, degree of the numerator and the degree of the denominator, and we have to compare them, right? So number 16 was the case when the bottom was bigger. When the bottom is bigger, the horizontal asymptote is at y equals 0. Here, the numerator's degree is bigger, okay? Now, I know you got the notes. I know you guys have that notes all organized. N is 2 and M is 1. And this is, I can't remember what case number it was, but when N is greater than M, guess what? There is no horizontal asymptote. I guess I can just go ahead and say none here. But I'm sure when you go to calculus, you will be able to use the limits. You'll be able to use limits to find these horizontal asymptotes instead of just using these cases. But anyways, now let's take a look at the last one. There was no horizontal asymptote for this function. But what about slant asymptote? Now, you remember, we have slant asymptote when n is 1 bigger than m. 1 bigger than m. And is that true? So in other words, if we do m plus 1, it should be n. That's like the condition that we need to have in order for a function to have a slant asymptote. And that is so true, isn't it? 2 is 1 bigger than 1 by 1. So we have a slant asymptote. So remember how to find it. You're going to find it using either long division or synthetic division. The quotient is going to be the equation of the slant asymptote. So I'm going to do synthetic division. You can do long division if you want, but I'm doing this. -5x squared plus 7x minus 2. I will divide this by x plus 4. So if I'm doing synthetic division, I put -4, the 0. I don't think that's a 0, because unless the remainder comes out to be 0, right? We put that -4 in the box. Put -5, the coefficient 7, and -2. Let's do synthetic division. Bring down the -5. Multiply and get 20. Add and get 27. And for synthetic division, for slant asymptote, we don't really care about the remainder because the slant asymptote is just the quotient. Well, let's just keep going. You know what? -4 times 27, what that is. But, remember, we don't really care about the remainder when you write the slant asymptote equation. It's just going to be the quotient. So let's write down the equation. The slant asymptote is at y equals, now remember we divided by x squared by x to the first power, right? So the quotient will have a degree 1. It will have a degree 1. It's going to be a linear function. So it's going to be -5x. And then this 27 is just a constant. So that is how you can find the slant asymptote of a function. It only exists if the numerator degree is bigger than the denominator's degree by 1. So if I make up a random function, if you have x to the 5th power minus 6, and if you have x to the 3rd power plus 2, we're not going to have a slant asymptote here because 5 is bigger than 3 but not by 1. So slant asymptote, if it exists, you can find it by finding the quotient. Okay, so that's it for this video. Let me know if you need anything. I'll try to record it and send it to you, but my entire family is about to come home now. So if that happens, it gets kind of loud, so I may not be able to record as fast as I can, but I'll try to get to as many questions as possible, okay?